Bismillahirrahmanirrahim. Assalamu alaikum. Today we are again starting with Mendeleev's periodic table and periodic law, which was proposed in 1869. This law is purely based on periodic function of their atomic weights. Remember that it is the periodic function of their atomic weights, and also we can say it is an extension of Newton's law of octaves. There are advantages of Mendeleev's periodic law that he left place for unknown elements which were not discovered at that time. Elements were placed in an increasing order of their atomic weights, and he developed foundation of periodic table by arranging in tabular format 7 horizontal rows called as periods and 8 vertical columns called as groups, which was the basic foundation of a periodic table. Now, Mendeleev also discovered some names of the elements which will be discovered in the future. So Mendeleev predicts the position and proposed names of not known elements at that time, which later were discovered as Eka boron, which we today called as scandium, Eka aluminum, which we called as gallium, and Eka silicon, which today we called as germanium. So Mendeleev's periodic table is the basic of the tabular format of periodic law, or we can say as periodic table. There was a crucial time, but Mendeleev disregarded his own periodic law. He placed argon before potassium, and he placed tellurium before iodine. So we'll move towards the modern periodic table, which was Moseley's contribution, proposed 1904 to 1913. This law is purely based on periodic function of their atomic numbers. Previous was depend on atomic weight. This is depends on atomic number. It is also known as extension of Mendeleev's law, but our consideration is on periodic table on electronic configuration. The physical and chemical properties of the elements are the function of the electronic configuration of their atoms, which way with increase in the atomic number. Moving towards half-power principle. Half-power principle is the basic of electronic configuration, and it shows which subshell will be filled first. So this is the arrangement of how S, P, D, F are filled. S contains 2 elements, P contains 6, D contains 10, and F contains 14 elements. And here we have the arrangement how much elements can one group contain. Here is the series how we can use the arrangement in an order to get any elements in a configuration in electronic configuration. Based on electronic configuration, there are formulas for finding which element belongs to which group and which block. I will discuss only S block element, remaining will be the same. So Cn is shown is the number of row, or we can say the period, and S shows the subshell of that element. So NS1 is all including 1A elements, and it shows in the S block element, and NS2 these are all dropped into A group, which is also S block elements. In a similar way, remaining electronic configurations formulas are according to the number of period and according to the subshell. Let's discuss an important topic about periodic table, about ionic charge. All reactions carried out through ionic charges by balancing ions. For example, +1 of the group first element reacts with the group 7 element, which is -1, which shows a strong bond in it because of plus and minus, and they are also in stable condition. If the valence electrons after the ionic charge are balanced, then it is called a stable reaction. So further topics and further about electronegativity, electron affinity, and remaining ionization energy, and all of these characters and non-metallic characters all will be discussed in the further topics with detailed information of how to periodic table.